Hello, everyone, and welcome to Inflectra's live webinar series called Test Automation Demystified. You're joining our 5th webinar in the series, and today's topic is Codeless Test Automation. Today's webinar will be presented by my colleague, Denis Markovtsev. Denis is a principal software developer here at Inflectra, and he's the mastermind behind Repease, Inflectra's test automation platform. He holds a master's degree in computer science and PhD in math, and has been working in the IT industry for over 20 years. Here with Inflectra for 5 years now, he's been researching the tools, technologies, and processes in the software testing and quality assurance space. My name is Taya, and I will be your moderator today. As usual, let's start with our housekeeping issues. Now, today's webinar will last for about 45 minutes and will be followed by a Q&A session. Please save your questions until that time. Please use a built-in questions tab in the GoToWebinar platform. And when time comes, we will be reading out your questions and answering them live. Today's webinar will be recorded as usual. In a couple of days, we will make the webinar recording available on Inflectra's YouTube channel under the playlist called Test Automation Demystified. Please note that this particular webinar playlist is called unlisted, quote unquote, for the duration for the webinar series. You will be given a direct link to access the recording through an email that goes out after the webinar. Or you can subscribe to Inflectra's YouTube channel and get notified every time there's a new recording in this series or in the other series that Inflectra is running on a regular basis. At the end of the webinar, we will have a very, very quick survey to get a better idea if the webinar content was relevant to your needs. Now, for those who are joining us for the first time, let's recap the key aspects of the webinar series. Now, firstly, Test Automation Demystified is Inflectra's introductory test automation webinar series. Its overarching goal is to help aspiring software testers to get a better sense of what's involved in test automation and what tools to use and how to go about it. You can learn more about the series by clicking on the URL shown over here, but also it is included in the handouts that you can access through the GoToWebinar platform. Some of you may know that Test Automation Demystified is a certificate course. The series participants are eligible to get a certificate of completion, given that they meet all the webinar attendance and quiz requirements. If you wish to get a certificate, you will be asked to take a short quiz after each webinar. To make things easier for you, we will send out a webinar follow-up email that contains all the materials covered during this webinar, including the link to each quiz, as well as the recording and so on. Also, if you need to take a look at the full set of certificate requirements, you can refer to the frequently asked questions linked here on the slide that you're looking at or in the handouts that we have included in this presentation. Last but not least, please note that each webinar in the series has a practical part, and we will be using our own test automation platform Repease for this practical part. If you haven't had a chance to take a look at Repease, you can download a free version from www.inflectra.com/Repease. Please do that so you can maximize the use of the webinar series. This is all for now from me, and I would like to hand it over to Denis. Denis, take us.
Thank you for the introduction there. Can you hear me? Do you see my screen?
Yes, everything is good.
Okay, very well. So today I'm going to talk about codeless test automation. What does codeless mean? Obviously, it means to code less and write less code. And even software developers use codeless techniques. They do not program everything. They actively use code generators, compilers, some visual composition tools, models. And so codeless test automation is not something new and specific codeless techniques, not something specific to QA and test automation. And it has deep roots in software development. So codeless is anything that helps us write less code. And why we need codeless? I think that we need it for two main reasons. So firstly, it should, of course, speed up the testing process and allow to produce more results in less time. And secondly, it should lower the learning curve and demand less knowledge, initial knowledge from a user of test automation tool. And this second aspect is very important. These days we use so many software systems that we simply have very little amount of time to spend on learning. And it is very hard to keep all the necessary details in active memory. So a software system should guide the user wherever possible. Who does codeless automation? Software testers come from very different background. Some come from manual testing, some are domain experts, and some are developers. And all of them should benefit from codeless features of a software testing tool. I would compare codeless approach with electric bikes. One of them is displayed on the picture. So if you have an accumulator on your bike, so it allows you to get further with less effort and requires less skills. So it allows everyone to enjoy the nature, mountains, lakes, and without ability to produce high power like a professional cyclist. So how to write less code in UI test automation? What are common ways of achieving this goal? So there are two mostly used ways. So first is still write code using one of high-level programming languages. So, and this is most widely used approach nowadays. So use high-level programming language and use a software library like Selenium or Appium that helps simplifying some tasks like connecting to a browser or mobile device and sending comments to it. And the second approach is to use a tool that provides keyword-driven testing features. And we'll sort this out in the next sections of this talk, what is keyword-driven. First option, writing the code, is still good old programming, and the second one, how it is implemented in the tool very greatly depends on the tool itself. Okay, so what is keyword-driven testing? First, what is keyword? It's a name. Basically, it's a name for an action to perform over the application that you are testing. And the keyword can simply have some input data to it. It can be a UI element to interact with and some data that a keyword needs to perform the action. For example, a text to enter in the text field. And these keywords, they can be low level and available in a testing tool out of the box. So for example, like do click or do set text, or they can be high level. High level keyword consists of some low level keywords. So let's see how it looks like in rupees. So here is the well-known library information system we used in other webinars of this series. This is rupees, and I'm going to record a few steps in the application. So clicking on the login, so the same login screen. Entering username and password, clicking login, click and finish. And here in rupees, I have low-level keywords on each line of the RVL spreadsheet. So here is the keyword do click on the second line, and it acts on login element. If we have a do set text keyword, of course, it needs the text that we want to enter. This is a set of low-level keywords. So how to create a higher level keyword in rupees? So it's pretty simply to do. In RVL, we can create a new sheet. So let's name it login, and we will create a high level login keyword. So I simply copy the steps to another sheet. I will copy them here. Of course, when you want to log in, you may want to log with different username and password. So this is why I will define input parameters for this high-level keyword. So I will define a variable. First variable will be username, and I can provide the default value for this variable, and the second one will be password. Here is the default value as well, and here in a set of low-level keywords, I just need to use those variables. I am selecting username and selecting the password. Okay, so now I have a high-level keyword. So let's see how we can use it somewhere in our test. So I will delete those lines from here. And now I will just call the high-level login keyword. So the object to use is RVL, and the keyword, or we call keywords actions in rupees. The action will be do play sheet, and the name of the sheet or high-level keyword is login. So what I need to do is to pass username and password to use to this high-level keyword. So I will just specify the values to pass. So let's have these values different from the default ones. So I will use borrower, password. Okay, so now we are ready to launch. Let's log out and move the system to initial state. And now let's just execute our test. And it should use borrower username and password to log in to the application. Okay. Here we define the high-level keyword using codeless technique as well. So it consists of lower-level keywords written in RVL. It's also possible to define a keyword using JavaScript. So if you want to code some complex logic for the keyword, it's also possible. So what I'm going to do is just copy these lines as JavaScript, go into JavaScript module of this test, and I will create the login function here. So if you want to code some high-level keyword, you can do this. So let's name the first parameter username. The second one will be string password. And here I just insert, okay, I need to copy this as JavaScript. Okay, something doesn't work. Okay, let's select it once again. copy JavaScript and putting it here. Okay, so this is like magnetic storms on Mars or something like that. So I will combine, create this function from scratch. So here is the login. Do click, and here is the elements I want to act on. So for the username, I want to set text, and it will be username. Okay, and for the password, we enter password. Okay, I will not be finishing this function completely. To call it from the test, we can just, as an object, we select functions. Here is the login function we just created. And here we just provide the values to pass to the application. So I now can do logout and execute my test, and it should enter the username and password into the application. Okay, so it works. In many tools, keyword-driven testing just stops at this point. And what is beyond keywords? So what else we can do in codeless mode? One of the goals of test automation is to use different sets of data in the same testing scenario. And usually data is put into external spreadsheet or a text file. It is a good approach, but it also can be improved. What about having data and keyword sections within the same view? So it makes test development actually more convenient, especially it makes it easier to select some row of data to use when you just develop your test. So let's go to the RVL spreadsheet and to our login sheet. So I will copy the lines that I need to the initial sheet. I will remove this, and I'm going to create a table with data on this sheet. So I am creating, in rupees it is called map. We can give it a name like logins, and we can specify the column names, username and password, and define some data. So what is good is that when you just work on your test, you have all the data that you use in front of you. So here we need to parameterize, and we need to use this table logins. Okay, fixing the test. So when you have the data, you know what the tool is using. And for example, if I want to perform login using specific set of data, I can just use this word in the flow column, and Tropis will use data from this specific row. So let's go to initial state and execute our test, and it should use borrower username and password. Okay, so it works. And here we have an example when data is inside rows. But if there are many data parameters, if you put everything into rows, the number of columns can be very great, and you will have to do scrolling to see the value that you may want to change. In rupees, you can also put the data into columns. So let's create a new sheet and name it configuration. And in rupees, we can create a map that has its values inside columns. Let's name it configuration. Okay, and here we have data in columns, and this is good to use for configuration. So, for example, you may execute the same test on a staging environment or on production environment. So let's create the row instance, and one will be staging and another will be production, and some parameters that may have different values depending on the server where you want to run your tests. So, for example, URL for staging, it can be kind of staging some port, and for production, it can be real URL. And also you can provide other parameters here, like do you want to do data seeding or not, and then in your test you can just read the data that you need from this set of data. Okay, so we have data in columns. Okay, we have keywords, we have data, and what's beyond. So if we can, so I showed how we can create linear sequences of steps. And actually, when you do test automation, if you can, it's better to always use linear sequences of steps. But if you have a complex scenario and it is absolutely necessary, you may go with loops and conditions. So typically, conditions and loops are perceived by people as almost programming, but in rupees you can also create them without coding. So let's see how to do that. So here we have a table of data. What if you want to run the same steps using all the rows in this table? So first, I need to add just one step here to log out after we successfully logged in. And now I can wrap this selection into loop. So wrap selection into loop. And this loop will use data from the logins map that we created. So now without writing any line of code in the text editor, we have a loop that will repeat the same steps for different rows of data. Okay, logging out from the application. And now I can play my steps. And it should use, first it should use librarian, and on the second iteration, it should use borrower. Okay, the first iteration, the second borrower is used. Okay, so we have a loop and we are testing login, but login can be successful or unsuccessful. So how we can check that? So to check that, we may need a condition. So let's just add one condition to our test. So before doing the logout, I'm going to insert the condition. And when you do this in rupees, you first simply select the if in the flow column, pressing tab key, and rupees generates the template for the conditional statement. And what we want to do, I want to check that when login is successful, we see here in the top right corner logout text. To do that, I select the condition that should compare the output of some action that we will fill out later with parameter of this loop. Okay, we'll be acting on the login element, and to read the text that is written on this element, we need get inner text. So this is one of the properties that we can read from this element, and we want to check that the text is logout, and if it is successful, so let's just print into report. So the tester will print the message that login successful. And if login is not successful, we need else part of the conditional statement for that. We will print that the message and that login is not successful. Okay, so and let's now just change their data here to something where login will not work. I just changing the username and password to something that will not be accepted by the system. So let's execute our test and see what we will have in the report. So first, librarian is okay. And then system enters visitor. Okay, not successful. Okay, and what we have in the report, first time login was successful, and the second time it was not successful. And we got this result by using a conditional statement. Okay, moving on. So the state. So keywords and loops conditions may not be enough to implement really complex scenarios. And sometimes you may need to remember some values during test execution. And this is where you will use variables. So let's go to RVL and create one new sheet. The new sheet is variables. And I will create the variable. And I will name it username. All right. And how to get the value of the variable. So let's read what we see on some element. So let's log into the application. Okay. And let's capture the element to use for the username. So I will start recording. And I will just capture the element here. Okay. And now I will select this element here in the object. It is librarian. To read the text in the element, I will need get inner text. And to put the result of this section to the variable, I just need to select output here. So I want to put output of this action to the variable, and the name of the variable is username. Okay, so now I have I read the value from this element and put it into this variable. And then later in my test, somewhere I can use this variable. I select the parameter type as variable, and here is the username. So this is how you can declare the variable, define it, get the value of the variable, and how you can use the variable in your piece. Okay, but stop. You may say that loops, conditions, and variable, it is programming. So though we did not write a line of code in a text editor, but we use more and more some of programming concepts. And I will say that this is actually inevitable, and this is because computers still do not understand natural language as humans do, and we have to speak in computers' formal way. So, for example, if you will look at voice assistants like Alexa or Siri or Google Assistant, you will see that even these cutting-edge technologies understand very limited number of sentences, and those sentences are built in a very, very specific way. So here we have an example from things to try that Alexa sends every week. Like, Alexa, what temperature is Miami in the summer? So this is a sentence with a very, very specific structure that is understood by computer. But testing, actually, QA and testing and test automation is much more complex thing than just finding information about weather conditions in Miami. So unfortunately, while computers do not understand natural language and cannot read our test cases and execute them on their own, we need to speak computers' language, and we need to employ some programming concepts. Okay, what's next in the Codeless? If your scenario is long and there are many steps that are repeating, or it is just very, very long, you need a way to break down the steps into some manageable pieces. And you may consider to group the steps into high-level keywords, like we did in the beginning of the webinar, or you may consider just even to put those steps into a separate test. So in your piece, you can, for example, you can create a subtest. Let's name it login. I will use the objects that we already captured during recording. Selecting Firefox, using RVL. So I can just put the steps that we have here. Okay, let's just copy all those steps and put them into a new test we just created. Okay, and now we can just launch this test from the parent test that we had prior to creating the subtest. So I will delete these lines here I will delete the loop that I don't need anymore. And here to execute another test, we use a global object, and we have do play, do invoke test. And here is our subtest that we created. Okay, so now we are ready and we can execute the steps that are defined in another test. And if we have such a subtest, we can reuse it in many other tests. So this is how we do decomposition in rupees. Okay, and at some level of complexity, you may need some very low-level things in your scenario. And if you have a programming experience, you may also want to just use coding for some specific parts of your test. So, and in rupees, when appropriate, you can just use power of coding in a keyword-oriented environment. So how to do that? The first thing that works everywhere in RVL is that you can use JavaScript expressions. So for example, let's create a new sheet for demonstration. Okay, it is here. So let's print the number of seconds within a single day. So to do that, we use tester object, message action. And to calculate the number of seconds, if you don't remember the number of seconds, you can select expression. And it means that param value is just a JavaScript expression. So here I can write 60 seconds, 60 minutes, 24 hours within a day. So, and if I will execute this part of the test in the report, I will have the number of seconds within a day. Also, if you prefer coding, then you can define a function like we did in the beginning, and then you can call this function in anywhere in RVL. So you just select functions object and select your function from the drop down and specify parameters. Okay, so now we considered different features of the codeless approach, and let's now speak about benefits of this approach. So I think that the main benefit is the codeless approach makes possible to work at different levels of complexity. So first, when you are just starting doing test automation and maybe you are not familiar with the tool or you don't have programming experience, you can start at level 0 and you can just use recording and playback. So then when you are comfortable with the tool, you can do modification of the test. You can select the elements to interact with. You can select actions. You can specify parameters. You can even make your test data-driven. Next level of complexity, you can add some control flow structures. You can use loops, conditions, all these things. Then you can do some architectural decisions, and you can decompose your test coverage. So you can think in terms of test coverage, how you break down different pieces of your tests into implement using different tests in rupees and call one from another and split the work between team members. So all this can be done. And at the maximum level of complexity, you can also use coding, and here you have the full power of JavaScript, and you can code almost anything that you want. Another benefit of the codeless approach is that it does not require to remember the syntax. So there is no so-called syntax sugar, and the system guides you on all your steps. So let's look at the examples on this page. So in example 1 is just a line of code in JavaScript. And since programming language were designed for people by people with mathematical background, they are easily read the example 1 as what we see in example 2. So deposit $17.99 to John O'Connor. And if we look at example 1, here we have round brackets, we have some apostrophes, we have a slash, and all these symbols do not have meaning for the actual action that we want to perform. And those symbols are called syntax sugar. And this syntax sugar makes problems even for programmers. So when you switch from one language to another, and those languages are similarly looking, some differences may really cause frustration. So if you look at example 3, if you write this line in JavaScript, it will mean that you just concatenate two strings. And if you write the same in PHP language, it will be a mathematical operation. If you look at example 4, and this comparison of value variable with OK string is fine if you are using JavaScript or C#, but it will always produce a false result in Java language. So even if we have programming skills, it is still a problem to switch from one language to another, and it may lead to potential issues. So in RVL, in codeless approach, the number of this syntax sugar is minimal. And you don't need to remember the syntax. You don't need to remember the syntax because the system guides you along the way. So for example, if you want to add a new step to your test, you just select the element to interact with. So you just expand the drop down, you specify, you select the element, then you go to the action cell. Here you also can expand the drop down, you can select the action, and you added the step. So I added this step just using mouse or without touching the keyboard. And if this action is something more complex, then do click. For example, if we are entering text to do set text to username field, all we need to do is just enter the value here. So the system guides you. And even when you do logic like loops and conditions, Rapis also helps you. So you don't need to remember how to do this. So for example, we may select loop from the drop down. I'm pressing tab key, and Rapis asks you how you want to loop. Either you want to loop through rows of some table, or you want to check some condition, or you want to check value of some variable. So Rapis generates all the syntax for you, and you just need to enter the real values. So you use a mouse to select something from drop downs, and you use keyboard to enter actual values to be used in your test. Another benefit is that you can execute almost any part of your test. So you already saw this. So you can execute the whole test. You can execute a specific sheet. So this is very convenient when you do test development. You can record different pieces separately. You can debug and troubleshoot them separately and execute them separately. Also, you can execute just a part of the steps that you have. So this is all very, very convenient. The next benefit is, this is one of my favorite, is in Codeless Automation, you also can extend Codeless features at the user level. So for example, you may define additional columns in RVL and enhance the keyword-driven approach that you are using. So let's look at the example. So here we have, let's have some steps in our initial test. What if we want to use, okay, let it be logins. What if you want to use column H to provide special instructions during test execution? In my example, I will do the following. I will extend the system in a way that, depending on the string, on the value that I enter in the H column, repeats will be taken a screenshot of the element and added to the report. So to do that, so it requires some coding, and this coding can be done by a programmer, and the result is used by the rest of the team. Okay, let's go to JavaScript part, just put this piece here. And after adding this part, my H column now have a special meaning. If I add SB keystroke here, it means that take screenshot before taking the action. If I enter SA, it means that taking screenshot after entering the value into the field. So let's do this and do some screenshots. So we are doing screenshot before clicking on the button and after entering the text into the edit field. So let's see how it works. Logging out, play. So the values in the H column instruct the tool what to do during execution. And here we have the screenshots of the elements that were captured during playback. And also we have all the screenshots on the one page. So with custom columns and triggers, it's possible to do a lot of cool things. For example, you can do like automating printing of data to a report or some external file, or you can specify ID of a requirement that is tested by a specific piece of your test. So you can extend the Codeless features of RPs. Okay, there are many benefits, but what are limitations of codeless approach? Okay, so the limitations depend on the complexity of your testing scenarios. So if your scenario is just a linear sequence of steps, then codeless is an absolute winner here. But if the scenario is very complex and it is absolutely necessary to implement it, in some cases it may be more effective to use coding. So let's talk more about selecting scenarios for codeless automation. So when you just start doing codeless test automation, I recommend to start from recording and playback. And remember that test automation, it's not a manual testing, and not all manual testing scenarios should be or can be automated. The idea of test automation is to offload some boring checks from manual testers. So at least for the beginning, long end-to-end scenarios with switching between windows, applications, and conditional logic should be avoided. And when you are comfortable with the short recording and playback tests, just proceed to data-driven testing. Then you can try loops and conditions, but try to not overuse them and try to keep scenarios simple. If you plan on doing many tests with common steps, then definitely you need an architect in the team, someone who will design the test coverage and make a breakdown into building blocks, will define high-level keywords. And from certain level of complexity of your scenarios, you may need a real programmer in the team and try to use his or her resources wisely. A programmer should implement low-level helpers and make them useful for the whole team. So usually just one programmer for the team is enough to implement pretty complex scenarios. Also, if you have domain experts in your team, they should be mostly busy with data tables and be a driving force for data-driven testing. And remember, so as good accumulator should open great possibilities for electric bike owner, as codeless test automation should save time for QA team and make testing easier and more effective. So this is the goal of the codeless approach. Okay, so the next webinar will be mostly devoted to the last slide of this webinar. It will be about implementing common scenarios in test automation, and how far you can go with codeless automation depends on how you define your scenarios. Even if your application is automation friendly, it doesn't automatically mean that you will succeed with testing the application. If test automation is managed in the same way as manual testing, then you are likely to hit some roadblocks, and we'll talk about those blocks in the next webinar. The presenter of the next webinar is Alexey Grinevich. So, and now we are opening for questions.
Fantastic. I think we are on the hour now, and I just wanted to take a minute to say thank you to everybody who attended today's webinar. And just as mentioned earlier, please be on the lookout for our follow-up email with the recording of today's webinar in a couple of days. And again, our next webinar is scheduled for July 24th at 10 a.m. Eastern time, and that is going to be dedicated to common scenarios and test automation. Thank you again, and have a great rest of the week. we hope to see you soon.